we are going to find the derivative here. So f prime of x. This is a pretty straightforward derivative. It's just 2 cosine of x. And then for critical points, we want to know where 2 cosine x equals 0. So we're going to say 2 cosine x equals 0. We will divide by 2. So cosine x equals 0. And then we need to ask ourselves where from 0 to 2 pi, which is the unit circle, does cosine equal 0. So we're thinking about that unit circle. And cosine is your x coordinate. So it is here at x equals pi over 2. And right here at x equals 3 pi over 2. Those are our critical points. So we have to test our endpoints and our critical points, right? So we're looking at 4 different numbers here. We got 0, we got pi over 2, we got 3 pi over 2, and we got 2 pi. Now, to test, you're plugging back into the original because you want to know what the highest y value or the lowest y value from the original function is. So we are going to find f of 0. So that is 2 sine 0 plus 1. Sine of 0 is 0. And you'll just get 1 for that one. Then we got to do pi over 2. I like to do them in order. It really doesn't matter whether you do them in order or not. So we'll have 2 sine of pi over 2 plus 1. What is sine of pi over 2? 1. So we got 2 times 1 plus 1, which will give us 3. I bet that's the maximum. We got 3 pi over 2. So 2 sine of 3 pi over 2 plus 1. What is the sine of 3 pi over 2? Negative 1. So we get negative 1 right there. I bet that is the minimum. But let's check the 2 pi as well. So 2 sine of 2 pi. 2 pi is back around to that same point where we started. So we get 0 plus 1. And just, oh, not 0, 1. There. So we are looking at these numbers to decide which one is a max, which one is a min. So right here's your max. And right here is your min. And the best way to answer this, if it's free response, the best way to answer this is to say the absolute max of f on the interval from 0 to 2 pi is y coordinate 3, which occurs at x equals pi over 2. That's the best way to say it. And then you're going to make a similar statement for the minimum. The absolute minimum of f on the interval from 0 to 2 pi is y coordinate, which is negative 1, which occurs at x equals 3 pi over 2. Technically, the way this one is written, that which occurs at pi over 2 and which occurs at 3 pi over 2, is not required. You wouldn't have to write that. But it's just so safe to write it this way, because sometimes they're asking you for the x coordinate, sometimes they're asking you for the y coordinate, and this covers both there in case you misread what they're looking for. you like to live on the wild side, leave off which occurs at pi over 2. There. Okay, questions? So if it's asking us for absolute maximums or minimums on a closed interval, we want to take the derivative, find our critical points, and then test all of our critical points and endpoints to see which one's highest and which one's lowest. All right. We are on a limited time frame here, so I think I'll skip number 9. Number 9 is very similar to number 8. It is just going to be more complicated because you have a more complicated derivative there. So I think we're going to skip that one though. Which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum on the interval from 0 to 4? So some of these are not going to be, there's not going to be a guaranteed maximum. That is because, what is the condition for the extreme value theorem? What has to be true? The graph has to be continuous, right? So, really, they could have just asked us which one of these is not continuous on that interval. So, if I think of tangent, tangent has a bunch of vertical asymptotes, right? Anybody remember where those vertical asymptotes are at? I don't think so. I think that's, I'll be honest, I have a little trouble remembering too. I think it's pi over 2 is going to be like the first one there in the positives. But I have a little bit of trouble remembering. But I know how to check in a way that I am going to know. Tangent is sine x over cosine x, right? What is going to cause an asymptote? Denominator equals 0. So cosine of x is going to equal 0 at x equals pi over 2. Also, x equals 3 pi over 2, and so on. But pi over 2 is 3.14 something divided by 2. Is that between 0 and 4? Yes. So you have a vertical asymptote of tangent in this interval. It cannot be A. I'm going to think about the other ones before I have to think about inverse tangent, because I'd rather not do it. But, so, C, I would need to factor this. This is going to be x plus 4, x minus 4 in the top, and in the bottom, it's going to be x plus 5, x minus 4 there. And it really doesn't matter whether or not, thank you. We got to change your attendance here real quick. Oh, wait, I don't need that anymore. Uh-oh. What happened? They, like, locked it in. Hold on. I've got to email Miss Hankins real quick. Okay? All right. So, in this case, we have x equals, oh, cut it off. There. But I did cut my recorder back on. We got x equals -5, or x cannot equal -5, right? And x cannot equal 4. 4 is just a whole, but it really doesn't matter. We're talking about continuity, right? And if we flip back up here just for some reassurances, here, oh wait, no, that's the wrong thing. Here, it says if f is continuous on a closed interval from a to b. So it has to be continuous even at the endpoints. Is this one going to be continuous at the endpoint? No. If it was just that -5, we'd be okay, because it's not on the interval, but the 4 is the problem here. If we go to D, we have the denominator right there, e to the x minus 1, it can't equal 0 because if it does, it's going to give us a discontinuity. So if we move our 1 over, we got e to the x equals 1. And then we will natural log both sides. And so x will equal natural log of 1. What is natural log of 1? It is 0. That's one we need to make sure that we know right there. So natural log of 1 is 0. That's our other endpoint, right? So can D work? No. So I feel grateful for this because that means I don't have to think about B, which is an inverse trig, and can have, it has, inverse trig is actually continuous, so we don't have to worry about it. Okay? All right. Okay, let's look at this next question. It says, let f be a function with selected values given in the table above. Which of the following statements must be true? By the intermediate value theorem, there is a value c in the interval from 0 to 3, such that f of c equals 2. 2, by the mean value theorem, there is a value c in the interval from 0 to 3, such that f prime of c equals 2. And 3 is by the extreme value theorem, there is a value c in the interval from 0 to 3, such that f of c is less than f of x for all x in the interval from 0 to 3. Okay, so what do you guys think? Okay, intermediate value theorem, that just means we got to cross something, right? So we got 0, the point 0, 0, we got 3, 6. Does f of c have to equal 2 at some point? Okay. Mean value theorem, that's where our slope through the endpoints has to equal the derivative at some point. So if I use the point 0, 0, and 3, 6, and I do 0, 0, 3, 6, I'll have 6 minus 0 over 3 minus 0, and that will give me 6 over 3, which is 2. And then the extreme value theorem, it says between 0 and 3, there has to be some value such that f of c is less than f of x. What does it tell us if f of c is less than f of x? What point? What type of point would that happen at? If f of c is less than every other point on f of x, then this is talking about an absolute minimum. Okay? So what do you guys think? It's feeling like it should be D. It's not D. Why is it not D? Yeah. Feels like 2 should be right, but it also feels like 1 should be right. An extreme value theorem just says it has to have an absolute minimum. That feels right. It doesn't state that it's continuous or differentiable anywhere. The answer to this one is none. None of those have to be true because all you have are points. Nothing there tells you that it's continuous. For mean value theorem, it would also have to be differentiable. For 1 and 3, it would only have to be continuous. Like they could give you the same equation, like the same thing, and tell you that it's continuous, but nothing about differentiability. And then you could say like 1 and 3 would have to be true. But they don't give you any of that, so it has to be A. You don't know anything. Since they don't give you continuity, you can't prove any of those things for that. Not from a table. Now, if they gave you the function, like if f of x was 3x squared plus 4x plus 5, we know quadratics are continuous and differentiable, so you could do it there.
What if they give you like a graph?
You could probably do it from a graph because you could tell from that graph whether or not it was continuous. Yeah, so from a graph it would be okay. There. All right. So, last night you guys, or well, Monday night, whenever you chose to do that. You guys had 7 through 10, and we did 21, 23, and 25, right? So that's what I'm going to come around and check. And I would like for you guys right now to try, let's see, which one do I want? Oh, I'm on the wrong page, so I need to get on the right page first. Oh, I think let's do 41 and 43 right now. While I'm checking the homework. Okay, try 41 and 43 while I'm checking that homework. Yeah. Yeah. It would be a good idea for me to do that. So, like, we've got the critical points. On the other problems, you're down to, like, the easy part, right, where you just plug the numbers back in. And you just see, oh, this is 7, this is 4, this is 12. 12 is my maximum, right? This one, the plugging back in is about the hardest part, right? Especially if it's calculator inactive. And I have seen some like this calculator inactive. They're wanting you to use, well, I can't remember exactly what's happening here, but I have seen, you know, something similar. I can't remember how close these two actually are. Maybe not exactly like this, but so when you plug in -1, you get 5e to the -1 minus e to the 2 times -1. And I went ahead and changed these back to like fractions here because it's really hard for me to picture what's happening whenever we're talking about negative exponents. So this is going to be 5 over e, and this will be 1 over e squared. And I stopped right there for the moment. Okay. For h of natural log of 5/2, you're going to have 5e to the natural log of 5/2. The e and the natural log cancel. Over here, the e and the natural log do not cancel because of that 2 in between. But if you do like I did over here, and you rewrite that as e to the natural log of 5/2 squared, right? Or we could have just plugged it back into, if we just plugged it back into this line right here anyway, that might have been easier to do. I might should have done that from the beginning. Then the e and the natural log can cancel. So I've got 5 times 5/2, which is going to give me 25 over 2, minus 5/2 squared. So that's going to be 25 over 2 minus 25 over 4. And you got to get common denominators to subtract those. So that'll be 50 over 4 minus 25 over 4, which will give you 25 over 4 here. And we could probably actually get like a decimal for that. So we can like picture this. So 4 will go into 25 6 times, and then you'd be 1/4 would be left over, so 6.25 is what we're getting there. This is mostly for comparison reasons, right? And then plugging in for 2, not that bad. You just get 5e to the 2nd minus e to the 4th. What's difficult about this is deciding what's the biggest and what's the smallest. Okay? So, e is approximately 2.71828. That many decimals is not really necessary for your estimation here. It's about 2.7, right? So, if I have 5 and I divide it by about 2.7, right? If you write any of this down, make sure you put a squiggly equal sign because this is not equal to. So, if I divide 5 by 2.7. What kind of number am I going to get? What's going to be close? 5 divided by 2.5 would give me 2, right? So, like, it's a little less than 2. It's a little less than 2. Like, I'm gonna go 1.8. This is some real rough estimation right here, right? Like, if you write, I would probably mostly do it in my head, but if you need to write it down, make sure you got a squiggly equal sign because you are estimating right here. And then you're subtracting 1 over 2.7 squared. So 2.7 squared is going to be a little less than 9. So a ninth is like 0.11 repeating. So like, let's go with the 0.2. Squiggly equal sign 1.6. Really rough estimation there. But does it allow us to compare it to 6.25? Like, I feel pretty confident that this is going to be smaller than 6.25. I don't think I'm that far off, right? So, so between these two, this would be the maximum here. We also need to do something similar here, although a little tougher, right? Well, in a way, a little tougher, because I don't know what 2.7 to the 4th power is. But 2.7 times 2.7 is like, it's going to be a little less than 9, right? And 2.7 times 2.7 again would be a little less than 9. So, like, even if we do a squiggly, if it's like, let's call it 8, right? So if we do 8 times 8, that'd be 64. So that would be, the biggest thing that you need to know right here is going to be negative something, right? It's going to be negative 40 minus 64 would be 24. Probably pretty far off. Let me get the calculator out just to see. 5e squared minus e to the 4th is negative 17.65. Not that close, but I'm negative, right? And then, let's see, up here, 5 over e, some parentheses, 5 over e minus 1 over e squared. That's 1.7. That's pretty good, I feel like, for what we were doing here. So, I can tell here that this is my maximum, and we won't take the time to write out the absolute maximum is 25 over 4, which occurs at natural log of 5/2, but you could, right? This is my maximum, and then this is my minimum right here. Don't use your estimates. Use the exact values. It would be okay to use 6.25 because that is exactly 25 over 4, but don't use your estimates. Use your exact values for that. So these might be tricky, but they should give you something that you could estimate to at least know which one's highest and which one's lowest there. They should not, they won't give you one of these problems where like this one is 1.7 and this one is 2.1. Like that would be too hard to distinguish. They'll be far enough apart that you can at least tell which one's biggest. Okay. We are so running out of time. There's no way I'm going to get to an FRQ. I will make a video of one of the FRQs. Let's look at them real quick. Is there one? I can't even remember what all was on there. Let's just pick one and I'll make a video for it. We should do 43, but we're going to be out of time, so I'm going to move on to the notes. But for this week's, let's see which one I would suggest. I think I put that it was calculator active for one. One is different because it's calculator active. When you get to an equation, you're going to have to use Desmos to graph that. But it's relatively straightforward, except for you're going to need to use Desmos to solve. C's a little tricky. 2 is a little bit of a different question. It's not that hard, but it's different. 2 is not calculator active, and 3 is not calculator active. I did not. I meant to put it on there. 1 is calculator active. Now, it was a weird time of AP testing when they let kids use a scientific calculator. Which is like, basically like your phone calculator. It like won't graph, but it will take like square roots and do trig and stuff. Although we would use Desmos for it. So if you get that one, it'll be Desmos that you can use. I would say that 3 is probably the most straightforward of all of them. It's pretty straightforward there. How about I do this? I will do a video where I work out part C because it's a little bit different, and I'll work out part B and C on number 2. Because these first parts are just finding the derivative and showing that it equals that, and I think we're pretty strong with that. You guys do really well with those problems. You do not need the calculator for A at all. And the only reason you need the calculator for B and C is because you're going to get like 2y to the third plus 6y equals 1, and we don't know how to solve that by hand without having to do like synthetic division stuff. That I think I don't remember what they did on that. 3. Did we? I don't know. But yeah, we're going to use Desmos. They won't make you do it on the AP exam anymore. They used to, but they won't anymore. And I think where this is an older question, that's the reason it's there. Okay, so if I look at this graph that I have here, it tells me to sketch the lines tangent to the graph at the points where x, that should say equals, not whatever it says there, G, H, J, K, and M. So if I were to draw in little tangent lines, so like right here, my tangent line would look like this. At H, that tangent line would look like this. At J, that tangent line would look like this. At K, be back down here, and at M over here. Okay, so in these notes, what we're going to be looking at is where functions are increasing or decreasing. Okay, so if you remember from pre-cal, when we're talking about increasing to decreasing, we always go from left to right. So if we start over here on this left side, if we go from here to here, what's my function doing? Increasing. Okay. What do you notice about your tangent line right here? It has a positive slope, right? Then when I get to this point right here, what's my tangent line? 0. Then from H to K, what's my function doing? Decreasing. What do you notice about the tangent line? It is decreasing, which means its slope would be negative, right? And then I switch again, right? What is my slope of my tangent line here at K whenever I switch from increasing or decreasing to increasing? 0, right? And then I'm increasing. What do you notice about your tangent line over here? Positive. So if the derivative of a function is positive, remember derivative gives you the instantaneous rate of change, right? If the rate of change is positive, the function is increasing at that point. If the derivative of a function is negative, or that rate of change is negative, the function is decreasing at that point. Now, we did this in pre-calc. We just didn't call it the derivative, right? Whenever we talked about the increasing or decreasing, we talked about the rate of change being positive or negative. We made us a little chart about the rate of change and all that. All we really have to do is change the word rate of change to derivative, and it still holds, right? Because that derivative right there is your rate of change. So, if we look at a problem like example 1, if we wanted to, we could make us a little chart. I think I will. I think it's helpful. Over here, if f is increasing, then we, on our chart in pre-cal, we put rate of change right here. But I'm going to now just call it f prime. It should be positive, right? And if f is decreasing, then f prime should be negative. And let's think about this right here. If I'm switching from increasing to decreasing, or decreasing to increasing, doesn't matter which direction, right here, what does my derivative have to be? It's going to most often be 0, but it also could be undefined. So, we will sometimes be given problems like example 1 where we have to find the intervals where f of x is increasing or decreasing, but they don't give it, like it's not calculator active. You can't graph this. Now, I do know that this would be quadratic, right? And it would open upwards. So it's just going to have like one minimum point there. It's going to be, you know, over here it's going to be decreasing on the left side and increasing on the right side. I know that's going to happen. But I need to know where exactly that is going to happen, right? So, what we can do for this, back in pre-cal, it was a different thing. We solved inequalities, rational inequalities. And what we did is we like moved everything to one side where it was less than or equal to 0 or greater than or equal to 0 or whatever. And then we made this like chart, right? So, that same strategy is going to be useful here because we want to know if the derivative is positive or negative. Now, in a problem like this, it turns out to be pretty simple. So we want to find f prime of x, which is going to give us 6x plus 4. We then want to find our critical points. These are our points where our derivative equals 0 or undefined, because those are the points where we're going to switch from increasing to decreasing or decreasing to increasing. So I will set this equal to 0, so I'll subtract 4 from both sides. I will get 6x equals negative 4. I will divide by 6. So x will equal negative 2/3. That's my critical point.
Since this is a quadratic, you would do like inequality on the left side and on the right, so increasing and decreasing, right? So
Yep. Yep. And so, like, basically for this, since we do kind of know what this graph looks like, we know that, you know, this is a quadratic that opens upward. Well, that means, like, if this is negative 2/3, I don't really know, like, the y coordinate all that well. It's not that important, but it's going to have to open upwards, so it's going to look like something like this. I may be way off as far as, like, where, in fact, it's probably going to be above the x-axis, but no, it's not. It'll go below. I may be way off on exactly what it looks like, but right here is where it's going to switch, right? So I could, at this point, like, sort of say what's happening here, but they want a calculus explanation for everything that you have given. So if they ask this, most of the time it'll say justify your answer if it's not a multiple choice question. So if I make myself, I'm going to make myself a chart here. It's going to be a tiny chart right here. I'm going to label that chart f prime of x. I'm going to put my critical point right here, because that's the only place like it can switch from increasing to decreasing. And then I'm going to choose a test point that's somewhere over here. What would be an easy number to pick below negative 2/3? Negative 1 would probably be like your easiest number. Oh, that doesn't look like a negative 1. That'd probably be like the easiest number to try to plug in right here. So, you know, you can probably do this in your head, but you're doing f prime of negative 1, which is, and it could be any number below negative 2/3. You could use negative 3, negative 5, negative 1,000, whatever you want, but negative 1's the easiest one to plug in. So if I do 6 times negative 1 plus 4, we're just plugging it back into the derivative. That gives me negative 6 plus 4, which is negative 2. So all you really care about is you got a negative in that section. All right? And then over here, I need a number bigger than negative 2/3. What would be an easy number to use there? 0 or 1. Both are very easy right there. So if I do f prime of 0, I will get 6 times 0 plus 4. And that will be positive 4. And all we really care about there is that's positive. So you have to give a calculus explanation for this. So you would say f is, when I have a negative derivative, I will be decreasing, right? If you wanted, you could add this like to your chart. The fact that f prime is negative tells you that f is decreasing. The fact that f prime is positive tells you that f is increasing. However, they will not take a chart as your only reason, and you have to write it out in words for these types of problems. So f is decreasing on the interval from negative infinity to negative 2/3. Now here's something that I find almost confusing, but it is how you're supposed to do it. You're going to use a bracket with that negative 2/3. The definition used for decreasing by AP just says that it's decreasing if the point is lower than the point before it. So even at negative 2/3, this point is lower than the point that comes before it. So it's still decreasing there. So it's decreasing on this interval because, and you have to give a calculus explanation, f prime of x is negative, or I like to just say is less than 0, less than or equal to 0 on this interval. Now what I find a little bit weird about this is f is going to be increasing on the interval from, I'm going to use a bracket, from negative 2/3 to infinity, because f prime of x is greater than or equal to 0 on this interval. I find it weird that f can be increasing and decreasing at negative 2/3. That seems impossible, right? But by the definition that you're looking at, it can happen. Now, here's the good news, is that there are actually some textbooks that teach that a different way using a different definition. So if you accidentally put a parentheses right here with either one of these, they're not going to count off. They'll still give you credit for the answer there. So it's not a huge deal that you do it correctly. In fact, I know for sure, I can remember learning this. I know for sure that my calculus teacher, who was a very good calculus teacher, she taught us that at a maximum minimum point, that you are neither increasing nor decreasing. You've stopped and you're turning around. There are some textbooks that do teach using a different definition where that is the truth. So, but it is not the definition that AP Calculus has chosen as the standard they're going to use. However, because they know there's like other definitions out there, they're just not going to count off for that. So, on a multiple choice, it's always going to have a bracket with it. They won't give you like a parentheses and a bracket and make you choose. And on the FRQ, if you accidentally do the parentheses, you're still good.
Is that all you need to justify your answer?
Yes.
Like if you didn't have the chart.
You could probably get by without the chart. Probably there. I think it's helpful to think about there. It is important to note, if f is decreasing, the reason is always f prime of x is less than or equal to 0 on this interval. That's the reason all the time, right? And then if f is increasing, it's because f prime of x is greater than or equal to 0 on that interval. Or you can say f prime of x is positive on that interval there. So those kind of like always go together. All right, let's see. I need to find what I feel like is most important for us to look at for you guys to be able to do. Okay, I really need to get 2 and 5 in. 5's going to be quick, and so I think we can do it. I think we can do, let's do 5 first. Okay? All right, so looking at 5. Now, here's what you got to be very, 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 very careful about. This is not the graph of f. What is this the graph of? This is f prime of x. But what are they asking us about? F. So we got to think about our little chart, right? F is going to be increasing whenever f prime is positive. And f is going to be decreasing when f prime is negative. They are asking us for decreasing, which means f prime is negative. What does it look like on the graph for f prime to be negative? Below the x-axis. So it is this piece right here, and it is this piece right here. Okay? You want to give the x-coordinates of that, the domain of that. So this would have an arrow that goes on this end. So this piece right here, the x-coordinates would be negative infinity to the x-coordinate right here, which is negative 3. And then you would also have x-coordinate right here, which is 1, over to x-coordinate right here, which is 5. We'll use brackets with all of that except for your infinity, because your infinities can never have brackets.
So why would you not do it to where,
Okay. Now, what kids do wrong every time is they'll say, like, they'll tell me where this is decreasing, right? But this is not the function they're asking you about. And in calculus, it's almost never going to be the function that you're asking about. In pre-cal, they would ask us about the real function. Every once in a while, they give you a hard problem where it says, this is the rate of change. They'd give you this type of problem, but they'd call it rate of change. But those were like really hard in pre-cal. In calculus, it almost never is asking you about the graph you're actually looking at for that. So it would be from negative infinity to 3 and 1 to 5 for that. All right, let's go back up here and see if we can get this one in. We'll see. All right, so this is the same thing that we just did on example 1. It's a little harder because the derivative is more difficult to figure out. So we're going to take our derivative. It is going to require a chain rule here. So we will have 2/3 x squared minus 9 to the negative 1/3 times 2x. Okay. we're doing a chain rule there. So like our outside is that stuff being raised to the 2/3 power. Our inside is the x squared minus 9. Now, I would clean this up before I would try to find critical points a little bit. So this is over 1. I would move this back down to the bottom of the fraction. So in the top, you're just going to have 2 and 2x, which will give you 4x. In the bottom, you're going to have 3 times x squared minus 9 to the 1/3. If you want, you can write that as 3 times the cube root of x squared minus 9. Okay, so for critical points, you want places where the function is equal to 0, or the derivative is equal to 0 or undefined. Okay, so you're going to do 4x equal to 0. That one's really easy to solve. You just divide by 4, and x would equal 0. So one of our critical points is 0. And then the other one, we got 3 root 3 of x squared minus 9 equals 0. So you're going to do a bunch of stuff that just keeps giving you 0. You're going to divide by 3. Now you got the cube root of x squared minus 9 equals 0. Then you need to cube both sides. Now you got x squared minus 9 equals 0. If you do those first two parts in your head and realize that x squared minus 9 is the only thing that's going to make that 0, that's fine. We would move the 9 over, so x squared equals 9. And then we will square root both sides. What will we get? Plus or minus 3 for that. So I would make a chart for this, and I would do it like we did those inequalities. So you're going to have -3, you're going to have 0, and you're going to have +3. What you really care about is f prime of x. Right? That's what we really care about. But in order to find f prime of x, it would be nice if we knew what 4x was and what 3 root 3 of x squared minus 9 is. So I can kind of do it piece by piece, right? So the top is super easy. If you plug in a negative, like a -4 here, you're going to get a negative. If you plug in anything between -3 and 0, you'll get a negative. If you plug in something between 0 and 3, it's going to be positive, and from 3 and beyond, positive. You guys kind of remember doing charts similar to this. With a little bit of a different context, but the same idea. Then, this part's a little tougher, but we're plugging in numbers here. So we got like 3 cube root of, I'd probably use like a -4 squared minus 9. So that'd be 3 cube root of 16 minus 9. 16 minus 9 is going to be positive. I'm multiplying it by a positive. That's going to give me a positive. Between -3 and 0, I could use like -1 maybe. So I'd have 3 cube root of -1 squared minus 9. Now that is going to give me 3 cube root of -8. Now, can I take a cube root of a negative number? Are you sure? In fact, in particular, that one is -2. -2 times -2 times -2 equals -8, right? So odd roots, it's okay if there's a negative underneath. This is going to give us a negative right here. If I plugged in a positive one, in fact, if I just do this, if I plug in a positive one right here, does it change anything? I would just square this. I'll still get a +1 minus 9. I'll get a -8, right? I'm going to get a negative right here. And then what about if that 4 right there was a +4 instead? +4 squared is still going to give me 16. Still going to get a positive number right here. Okay? And so whenever we set this up, what we're looking for is this bottom line. If you have a negative divided by a positive, you will get a negative there. A negative divided by a negative will give you a positive here. This is positive divided by negative. That'll give you a negative here. And then positive divided by positive gives you a positive here. This particular problem is asking me where f of x is increasing and decreasing. Let's make it a little easier to answer this. Let's just say increasing so that we only have to give one answer because we're going to have to write this out. We're about out of time. If my derivative is positive, my function is increasing, all right? So I would say that f is increasing on, now be a little careful right here. I said use brackets, but can x equal negative 3? If I plug negative 3 in, actually no, I might be okay in the original though. Actually use brackets, you're okay. I don't have to think about it that hard, do I? No, I'm okay. Alright. If we were doing something different, we'd have to think about that. So negative 3 to 0 and 3 to infinity, because, and the reason is always the same. F prime of x is greater than or equal to, or f prime of x is positive 0, or f prime of x is greater than or equal to 0 on these intervals. Alright, so we could have done more practice with that, but I think you'll have enough to be able to do the assignment that goes with this. For 1 through 8 on page 233, it's from a graph. So you are just doing the problems from a graph. And it gives you the graph of the function. So it's more like pre-calc right there. That should be quick. And then 9 through 20, on this section, I'll let you skip. Let's see, how many questions are there? 12 questions. I'll let you skip 4 of those. So if there's one you just get stuck on, you can skip 4 of those. Okay. That I'm going to check on Monday. Okay. So it needs to be done by Monday. And tomorrow there'll be a video up for your FRQ.